Hello, calculus fans. All right, so we're going to talk about a particular integration by parts trick. It's known as recycling. Okay, so let's evaluate the integral of e to the 2x cosine of 3x dx. Okay, so let's use our detail rule. So which is the one that's going to be used for dv? Whichever's closest to d in detail. Right, so we have an exponential and we have a trig. So exponential should be our dv. So our u is going to be cosine of 3x and our dv is e to the 2x dx. All these things are fairly easy to differentiate and anti-differentiate. So du is negative 3 sine of 3x dx and v is 1/2 e to the 2x. All right, so if we put everything in with our integration by parts formula, we're going to have uv minus the integral of v du. All right, so there's uv minus the integral of v du. Now I'm not going to stop too much and show you all the little individual pieces. This is where the advantage of having this on video helps you. You can always pause and look to see where everything gets put together. You can stop and see how did we get uv minus the integral of v du, and you can see how everything got pieced together instead of having me show you each individual piece. And don't be afraid to pause things every once in a while so that you can see for yourself where all the pieces are going. You, of course, should be taking notes as you're watching these videos so that you can stop and work things out for yourself every once in a while. When you're watching a video, you don't want to watch it straight through all the way as if you were watching a TV show. You should be making liberal use of the pause button and your notes. Okay, so if we clean up, now it looks something like this. Notice the minus. Minus got canceled out, and the 1/2 and the 3 came together to make a 3/2. Now we're going to integrate by parts again, and we're going to choose u equals sine of 3x, and dv equals e to the 2x dx. This is again using the detail rule. du is 3 cosine of 3x dx, and once again v is equal to 1/2 e to the 2x. Now if we just look at the integral on the right hand side that we were working with, integral of e to the 2x sine of 3x. All right, so same deal. uv minus the integral of v du, which we will again clean up to get this. Okay, now I want to combine this to see what we got. So remember that in the original integral, we got 1/2 e to the 2x cosine of 3x, and then when we evaluated the second integral, we got this whole thing right here. And if I distribute everything, then I'm going to get something that looks like this. Now I'd like to reorganize what we've gotten. So I'm just rewriting everything. But notice that this time, if I highlight the piece that we started with and the integral that we got at the end, aha, notice they are the same integral. Now, at first glance, you say, okay, this is bad. I got right back to where I started from. That means I didn't really make any progress. Well, it seems that way, except let's do this. Let's let j be equal to that integral that we're looking for. Remember, that's exactly the integral we're trying to compute. So if I put that into the equation, then I'm going to get something that looks like this. J is equal to 1/2 e to the 2x cosine of 3x plus 3/4 e to the 2x sine of 3x minus 9/4 j. Now, what we can do is we can actually solve for j. So I'll add the 9/4 j to both sides to get this. And then we'll get 13/4 j is equal to 1/2 e to the 2x cosine 3x plus 3/4 e to the 2x sine of 3x plus c. And since we're trying to solve for j, we'll just multiply both sides by 4/13. Now you might say, well, shouldn't I multiply the c by 4/13 also? Nah, not really. It's just a constant, so it doesn't really matter if I say that that's 4/13 c or just c. It's just an arbitrary constant. Okay, so that means this is our final answer that we've computed. So the idea behind recycling is that the thing that you're trying to compute shows up on the right-hand side, and then you just solve for that in the natural course of things. Okay, that's all for now.